In section 5.6, we extend the properties that we had of parallelograms to some special parallelograms. So remembering back to our last lesson, we had numerous things that were true about parallelograms, like opposite sides are parallel and congruent, that opposite angles were congruent, that the diagonals bisected each other, that consecutive angles were congruent. All these different properties are still true, but the other ones that are added onto that for these special ones I'm going to highlight in this lesson. So the first figure that I'm going to talk about is the rhombus. The rhombus, in addition to everything that a parallelogram has some additional features. So in addition to all the parallelogram things that are true, a rhombus also will have 4 equal sides. That means that I know that side BR, RH, HO, and OB are all the same length. So perhaps they're all equal to 7 as an example. In addition to this, we also know that the diagonals of each other are perpendicular bisectors. What does that mean? That means when they intersect, they form a right angle, and I know that they cut each other in half. So I know that BM is the same size as HM, and I know that RM is the same size as OM, highlighted in the pink. Again, remember that these two properties that I've highlighted so far in the rhombus specifically are in addition to all of the properties that were true in a parallelogram. And then the last thing that you should know is that the diagonals of a rhombus bisect the angles that they intersect with. So what that's saying to us in the blue highlight and the blue markings is that angle B, the big angle B, RBO, is chopped in half, and this angle RBM and this angle OBM are the same size. I also know that means that RHM and OHM are the same size. And I also know that BRM up in the top left and HRM are the same size, and BOM and HOM are the same size. So the diagonals chop the bigger angle into 2 congruent pieces. These are all the things that are true about a rhombus, in addition to all the properties that a parallelogram had in the previous lesson 5.5. So a rhombus is a very special parallelogram. The second special parallelogram that we're going to talk about is the rectangle. So again, a rectangle is a very special parallelogram. The thing that's special about it, there are multiple pieces. The first piece is that the diagonals are exactly the same length. So I know that when I'm talking about a rectangle, that the distance from T to E is exactly the same distance R to C. So for perhaps they're both exactly 7 units long, or 10 units long, or 12 units long. Again, these are in addition to all of the parallelogram properties. So all the rules that apply to parallelograms still are true. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other, all those things. But in addition to it, the diagonals are congruent. Also, the diagonals bisect each other. So as I look at what that's saying to me, I know that when they say the diagonals bisect each other, that I know that these 4 pieces, RA, TA, EA, and CA, are all the same size, because we just learned that the diagonals bisected each other, which means cuts them in half, just now in the orange. And just before that, we talked about how they're equal. So if each of the diagonals would have been 10 units long, then each of the resulting pieces would be 5 units long. Therefore, we have 4 equal pieces. And lastly, and probably the thing that people remember the most, is that the rectangle has 4 right angles. And you can see these 4 right angles in each of the corners. And these are the 3 extra special properties, in addition to all of the properties that are true of parallelograms. So a rectangle has, in addition to all the parallelogram properties, diagonals being congruent, diagonals bisecting each other, and 4 right angles. The last special parallelogram that we're going to talk about is the square. Again, just like all the other things that we talked about, a square is a parallelogram, but it has some additional features that are special. Just like in a rectangle, I know that my diagonals are congruent, meaning that when I look at it, I know the distance from S to U is the same as from Q to A. Also, I know that my diagonals chop each other in half, just like they did in the rectangle. So when I look at that, that means I know that SE, QE, UE, and AE are all going to be the same size. I also know that the diagonals are perpendicular to each other. You might recall that previously in the rectangle that was not true, although it was true in the rhombus. So you see the right angle here in purple. And in fact, that would create 4 right angles. Again, this is in addition to all the rules of a parallelogram. So one of the things that I would tell you is the thing that's kind of cool about the square is that I say it is a rectangle and a rhombus at the same time, meaning it has all the properties that the special parallelogram, a rectangle, has, and all the special properties that a rhombus has. So it is the most special of the parallelograms. Don't forget, just like all the rest of them, it has 4 equal sides, It has 4 right angles. We know that the opposite sides are also parallel to each other. We know that in addition to that, the diagonals are congruent. All these properties are being true in a square. So a square is the most special parallelogram. In fact, it's the combination of a rectangle's properties and a rhombus's properties. 3 special parallelograms: rhombus, rectangle, and finally here, a square.